I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic optical fibers and devices, the acceptance angle and numerical aperture. And these acceptance angle and numerical aperture are very important basic concepts when understanding the light propagation through optical fibers. And we know a phenomena is called total internal reflection. So this is the main cause for transferring of optical signal into the fiber. And the refraction is when a ray is incident on the interface between two dielectrics are of differing refractive indices. For example, if one medium is glass and another medium is air, both will have different refractive index. So in this case, refraction occurs and the angle of incidence phi 1 that will be shown in the next figure, and angle of refraction is phi 2, and it is related by a law is called Snell's law of refraction, and according to Snell's law, n1 sine alpha phi 1 is equal to n2 sine phi 2. So the refractive index of a medium, the velocity of light in a medium and velocity of light in a vacuum, and this is the refraction is shown in the diagram. And if we see there is two mediums, one is glass and another one is air. Glass is having higher refractive index and air is having lower refractive index, and because of these refractive index difference, the incident ray get refracted, and that is given by exit ray. Phi 1 is the incident ray angle at the glass interface, phi 2 is the angle at the air interface, and there will be partial internal reflection takes place. And in the next diagram we can see the limiting case of refraction and the critical ray at angle phi c, and in the third diagram we can see the total internal reflection exactly, that is the fiber get bent and it is refracted and it is moved towards to the next medium, and this is total internal reflection. And another important parameter is critical angle. So here the n1 is greater than n2, the angle of refraction is always greater than the angle of incident. So when the angle of refraction is 90 degree and the refracted ray emerges parallel to the interface between the dielectrics, that is the angle of incident must be less than 90 degree. So this is the limiting case of refraction, and the angle of incident is now known as critical angle represented by phi c, and this is given by the formula sine of phi c is equal to n2 divided by n1. And when total internal reflection is defined as when light is incident on the dielectric of lower index from the dielectric of higher index at an angles of incidence greater than critical angle. And now we are going to see the propagation of light through optical fiber. So any light wave which travels along the core and meets the cladding at the critical angle of incidence will be totally internally reflected. Therefore, light wave is propagated along the fiber core by a series of total internal reflections as shown in the diagram. And acceptance angle, the meridional ray for example enters the fiber core at an angle theta A, and incident ray B at an angle greater than theta A is refracted into the cladding and eventually lost by radiation. An acceptance angle is defined by the conical half angle theta A, and theta A is the maximum angle to the axis at which light ray may enter the fiber in order to propagate it is called the acceptance angle of the fiber. And there is another important parameter called numerical aperture, and this numerical aperture of the fiber is the light collecting efficiency of the fiber and is the measure of amount of light rays that can be accepted by the fiber. It is equal to sine of the acceptance angle, that is numerical aperture is equal to n0 sine theta A, or it is also given by the formula n1 squared minus n2 squared power 1 by 2. Here n1 and n2 are refractive indices of core and cladding respectively. And numerical aperture of a step index fiber is given by the formula numerical aperture is equal to n1 root of 2 del. And assessment, numerical aperture of the fiber, if the angle of acceptance is 16 degree, we can use the formula of numerical aperture, and the answer is D, that is 0.2. And we know the formula numerical aperture is sine of acceptance angle, and so from this we can understand, we can easily calculate the given value. Thank you.